Good morning, everybody. Sorry I can't be there today. I'm home with my daughter who is sick, so here's the notes for today. Um, Today we are starting Chapter 7, which is all about polynomials and factoring. So it's going to be quite a bit different than we've done in the past. Some of the skills that we'll look at today will be familiar to you with kind of adding like terms, but just kind of need to define a couple of things first before we get into that, because their chapter, like I said, is all about polynomials, which we don't know specifically what that necessarily means, or at least we haven't talked about it this year. You should know what it means from years past because you do cover this in middle school, but let's just, again, kind of like we've done in the past, reestablish some vocabulary, make sure we're all on the same page so that moving forward, if I reference a particular term or if I talk about a binomial versus a trinomial, you know what that'll mean. Okay, so starting with the smallest thing first, a monomial is any single thing. So it could be a number, it could be just 3, it could be a variable, so x, or a combination of those two, so something like 4x squared. All 3 of those separate things, I'll put commas in between so it's not all combined, all 3 of those are monomials. So a monomial has to just be a single term. There can't be anything added or subtracted within it. It can be multiplied with itself or within itself, or have a division happening, so be a fraction, but it has to just be a single thing. The degree of a term is the exponent of the variable. So, for example, the ones that we put up above, 4x squared has a degree of 2. So whatever that exponent is, that's just the degree of that term. So if I had something like, I don't know, x to the 5th power, degree is 5 there, because that's the number that is my exponent. We'll have something, the degree of a polynomial, but for right now, we're just talking about degrees of a single term. So then putting a couple of monomials together, so a term, kind of monomial and term we'll use interchangeably. If you have a bunch of monomials, a bunch of terms added together, then we call that a polynomial. Because if we look at the root words, mono is just one, single. Nomial is just, or M-I-A-L, meal, just means terms. So a monomial means a one-termed thing. Poly is just kind of the Greek, I think it's Greek, prefix for many. So it just means multiple. Polynomial is kind of a general term that just means we have a couple of different monomials together. Technically, a monomial is a polynomial, but a monomial is just a specific kind of polynomial. So we define polynomial as kind of the overarching term here, and then we have specific names for different polynomials based on how many terms there are. So a polynomial that has 2 terms, we use binomial. Bi meaning 2, just like bicycle has 2 wheels. Binomial has 2 terms. And then a polynomial with 3 terms, we call a trinomial. Just like tricycle has 3 wheels, a triceratops had 3 horns. Trinomial means that there's 3 terms. So some examples of what those could look like. We'll start with our binomial. So again, our binomial has to have 2 unique terms, 2x plus 3. For our trinomial, something like those first 3 terms that we looked at up in monomial, 4x squared. Oops, sorry. Let's just put it back in the same order it was in. We said 3 plus x plus 4x squared. The thing you have to be careful of, and we'll talk about this in a second, When we're looking at polynomials and defining how many terms they have, you have to look at unique degrees. So a degree, again, of each term means they have a different exponent on there. And in order for us to say, yes, there are this number of terms, we have to make sure that I can't collect any like terms within my polynomial. So here with both of these, all of my terms have a different degree, so a different variable and or a different variable's power. So that's why I can say, yes, 2x plus 3 is a binomial, 3 plus x plus 4x squared is a trinomial, because each of those three terms has a unique degree. Okay, standard form of a polynomial, so that's just how we will default to writing it, is in descending exponent order. So within our term, we would make sure that each power is the biggest on the left side, and then gets smaller in terms of their degree as you move to the right. So if we took the example that we were just looking at, the trinomial here, 3 plus x plus 4x squared, that's not in standard form right now. If I was going to put that in standard form, my highest degree has to go first, so that 4x squared term goes first. And then x to the first power, which is just x. And then that 3 doesn't have a variable at all, so it has like an x to the 0 power. So that would be my trinomial from above, written in standard form. And that's how I will usually present it to you. That's what I think for most of us looks the most natural, because that's how we always, at least we, math teachers, mathematicians, the writers of the textbook will write our polynomials. So you'll get used to seeing it that way. But some of what we'll work on today is getting something that is not in standard form into standard form, which is as simple as arranging the terms by their exponents. The degree of a polynomial, so that's a little bit different than necessarily the degree of individual terms. So a degree of the polynomial is just the highest degree of its terms. That is, put a little asterisk here, if there is one variable, it's just the highest degree. So for the one that we were just looking at, for 4x squared plus x plus 3, the degree of this polynomial would still be 2, because the highest degree of x is 2. Now that gets a little bit different if multiple variables. So if you have something, and this is not something we usually see moving forward, it's more so just with this section with identifying degree. If I have something that has multiple variables in it, so if I have something like, I don't know, how do I want to do this? 4x to the 7th power plus 8y to the 4th plus x squared plus y plus 3. When you look at the degree, and I'm just going to use d here for degree, it's the highest exponent on each different unique variable. So I have two variables in this polynomial. I have x and I have y. And the highest degree on x is 7. The highest degree on y is 4. So I would have to add those two together to get my total degree for the polynomial of 11. And again, that's a little bit unique. We don't usually deal with polynomials in multiple variables other than in this section. Most of the time, and when you're dealing with just a single variable, it's just the highest degree of that term. Or sorry, the highest degree of that variable. Okay, so other things to remind ourselves of, the coefficient or a coefficient we should know is the number in a term that is in front of the variable. So again, that multiplier. So if we look again, I'm just going to keep reusing this one. Let's duplicate that. So in this one, I have two coefficients, one that's obvious, one that's not so much. Here, 4 is the coefficient. For x squared. And actually we do also have 1 is a coefficient for x. Hopefully we remember that if we don't see anything out in front of my variable term, it's just a 1. Something else that I didn't include on here, but I do use this term quite often. I'll do this in red. This number that doesn't have a variable attached to it, if it's just a number, we call that the constant. And again, because x is a variable, it can change and adjust, but 3 is not affected by that because there's no x, so we just call it a constant. So for leading coefficient, it's the coefficient of the first term when you have it in standard form. So I can back up a little bit. So once you put it in standard form, the leading coefficient would just be whatever that first number is in standard form. So again, if I reuse the same one I've been using, 4x squared plus x plus 3, it's lead coefficient, which I'll a lot of times just abbreviate to LC. In this case is 4. I put it in standard form. That very first thing you see, that first number, that's the leading coefficient. So in this case, 4. So those are all the definitions. Now we just get to use them. And this is what a pretty standard problem will look like for just using the kind of definitions describing the polynomial. So for number 1, we have here, they want us to write -8 plus 9x squared minus 2x in standard form, and then identify the degree and leading coefficient of the polynomial. So again, those last two things will be easier once we have it in standard form. So we're going to go ahead and start by putting it in standard form. So once again, standard form means highest exponent term comes first, and then the next, we kind of go in descending order. So here my 3 terms are -8, positive 9x squared, and then a negative 2x. Now you have to make sure you're careful with this because the sign out in front, so to the left of your term, stays attached to that number. So when I rearrange this, that negative that's out in the very front of my polynomial, in front of the in front of the 8, is going to go with 8. It's not going to stay as the lead thing. So when I rearrange this, 9x squared is the highest degree term. It's got x to the second power. My next highest one is my negative 2x, because that still has an x in it, but not an exponent, so minus 2x. And then my constant is always the last term, because it doesn't have an x in it, so negative 8. So that's my polynomial in standard form. From here, my degree and my leading coefficient, which I'm fine with abbreviating if you want to. So D for degree, LC for leading coefficient. My degree again here, since it's just a single variable, is just the highest exponent, in this case a positive 2. And then the lead coefficient is that very first number in standard form, so a positive 9. That's it. Okay, flipping it on over. Number 2 is asking us to do that again, just the same set of instructions. The one distinction here, after they put it in standard form, they want us to identify the degree and then classify the polynomial by the number of terms. So for us, that just means, is this a monomial, a binomial, or a trinomial? Those are the 3 unique ones that we describe. Anything beyond that, there could be special names for it, like we could call a 4-termed polynomial a quadnomial, but they're not very common, at least in high school math. I mean, we definitely see them moving forward in Algebra 2, but they're not common enough that we would have a distinct name for them that we use on a regular basis. So that'll just be the one distinction between what we did on the front side and what we're doing back here. So for 2A, if it's a monomial, which is the case here, it's just a single term, there's nothing you have to rearrange. It's already in descending exponent order because it's just a single term. Nothing can go first or second if there's only a single term. So that's already in standard form, so we can just leave it like that. Its degree, in this case, is positive 4. That's the highest exponent term on a variable. And then classifying it, like I had said already, this is a monomial. Ooh, I can spell this morning. Monomial. Because there's, again, just a single term. Okay. Part B. Putting in standard form, again, descending exponent order. So now my 5x squared is going to go first, minus x plus 4. Again, descending exponent order. My degree is going to be 2. It's the highest variable, or the highest degree on a variable, highest exponent. And then classifying it, there are 3 distinct terms, so we call that a trinomial. Okay. Very last one, C. We've got 8q plus q to the 5th. So putting that in standard form, my q to the 5th, since that has the highest degree, that has to go first, plus 8q. That would be in standard form. My degree is 5, tonks. And my classification, sorry, my dog is whiny right now. Classifying it, there are 2 distinct terms, so we would call that a binomial. All right, so that brings us to our next skill, which is actually, I think, the easier part of this chapter, this section, because now that we looked at describing polynomials, now it's looking at how they interact with each other, which is what we'll spend most of our time on this chapter. Right now, and if you guys didn't see the title up here, this is just adding and subtracting polynomials, which is basically just adding like terms or subtracting like terms. So if I have a polynomial and I'm asked to just add them, it literally is just adding my like terms. So when I have addition, we know that nothing changes within my parentheses. So I'm just looking at collecting up my like terms. So x squareds with x squareds, x to the first power with x to the first power, and then my constants with constants, which, depending on how well you can keep organized, you don't have to necessarily do that kind of purposeful underlining, or some people, and I'll show you kind of different options on it, some people highlight in different colors, some people put different shapes around like terms. It's really up to you. You don't have to do that process, but for some people, doing that initially helps them to keep organized and make sure like terms are getting added with like terms, because again, for a like term, we have to have the same variable and the same exponent on that variable. So here, when I end up adding my polynomials together, again, my x squareds, I have 2x squared and positive 1x squared. So that's a total of 3x squared. I'm just adding their coefficients. X plus x gives me a 2x. And then negative 5 plus 6 is a total of positive 1. And it really is that easy. It's just literally collecting like terms for addition. Another option, you guys can all color different things, but if I keep it in single color, another thing that some people like to do, they'll box certain things. So here I've got x cubed. My second term does not have an x cubed. And then my third term, again, here we have minus x cubed. For x squareds, I'll go ahead and circle those. X squared in the middle term, x squared in the third parenthesis, and then let's like triangle x's, nothing in the last one, and then we'll just underline over here if we want to. So then going through and just collecting up your like terms, anything that is in the same shape or is underlined the same way would just get added together. So 5x cubed and negative x cubed is a total of 4x to the third. For my squareds, I have a positive 2x squared and a positive 4x squared, so that's a positive 6x squared. Whoops, I forgot the 3 in the middle. Here we've got 2x squared, 3x squared, and 4x squared. So that's a total of 9x squared. Forgot that middle one there. For my x's, I've got negative x and negative 4x. Those are my two triangled ones right now. So that's a total of negative 5x. And then for my constants, those are the ones that I underlined here. 7 plus 7 is 14, minus 8 would be positive 6. So that would be my simplified answer in standard form, 4x cubed plus 9x squared minus 5x plus 6. Okay, for subtraction, the only thing that's different with subtraction is, well, we know anytime we're subtracting is the same thing as adding the opposite. It's probably the first way that you learned it back in middle school in terms of polynomials. Or it's another way of thinking of subtracting actual numbers. Just like dividing is multiplying by the opposite, so multiply by the reciprocal. Doing the same thing here. So what I have to do, my first term in subtraction always stays the same, right? If I had like 5 minus 2, that's the same thing as 5 plus a negative 2. So I'm going to go through and switch the sign of that thing that I'm subtracting. So this first parenthesis stays the same. So negative 2x cubed plus 5x squared minus x plus 8. But since I'm subtracting this second parenthesis, negative x cubed plus 3x minus 4, if I'm subtracting that parenthesis, that's the same thing as adding the opposite. So minus a negative x cubed is the same thing as adding x cubed. I'm going to be actually subtracting 3x and then adding 4. So all I'm doing is really kind of taking this negative and distributing it in here to change all of the signs within that second parenthesis. And then once you do that, it is the same as what we were doing on the previous problem. Now we're just literally collecting like terms. So x cubed gives me, so negative 2x cubed plus x cubed is a negative 1x cubed. I only have my 5x squared here. There's nothing to collect it with. For my x's, negative 1 and negative 3 makes a negative 4x. And then my constants here, 8 and 4, gives me a 12. And that would be my answer. That's collected all together. So let's do one more. So again, my first parenthesis stays the same, x squared minus 8. And when I subtract that second parenthesis, I'm just going to switch the sign. So that's a minus 7x minus 4x squared. And now I just have to collect up my like terms, put it in standard form. So x squared and negative 4x squared gives me a negative 3x squared. And then since it's standard, hence the name, standard, it's by default, we put something in standard form. We're going to go ahead and subtract 7x and then minus 8. And that would be our answer. The only thing you have to collect together is those two x squared terms. Everything else was unique, so we don't have to add anything else together in terms of like terms. Hopefully that went fine for you. It should be mostly review. Shouldn't be anything kind of revolutionary in terms of new material. Homework is down here at the bottom of the page. It is 362, 6 through 38, just the evens. So page 362, 6 through 38, just the evens. If you're confused by anything, again, just like with that, always feel free to back it up, rewatch the video, rewatch certain parts, listen to me explain it again. Tomorrow I have planned on just doing a practice day on this, so that if there is anything you're super confused on, we can take that time at the beginning of class to kind of work through those issues, and then just do some practice with classifying my polynomials and adding and subtracting my polynomials. Have a good day.